We have to find, suppose we have to find the internal resistance of it. Suppose we are having this E and we have to find the internal resistance of it. What we do, we connect it here. Resistance box is just a combination of resistance we have put here. Okay, all internal resistance, external resistance, we put it here and we call it as a resistance box. Okay, and we call it as a resistance box. Okay, suppose what we do here, we take here, okay, we take here E. We have, suppose we are, there are two things. What we do, we first of all, case one, what we do, K2 is open. K2 is open. What will happen? Current will flow through this path. Okay, through this path, what will happen? We see if K2 is open, what we will get? We will get E1 is E is equal to 5 into, let us suppose L1. See, L1 length when K2 is open. Okay, now K2 is closed. K2 is closed. Suppose now we have closed K2. What will happen? Current will flow through this path and we are getting, suppose here our null point, another point. Okay, what will happen? Current will flow through this resistance box also and through this cell also. So after closing this switch, we will get next voltage and we will call it as a potential difference, and we will say it as like this, phi into L2. We have assumed A and 1 like this. A and 1 is equal to L1, and we have assumed A and 2 is equal to L2. We have assumed like this. Now we also know I is equal to how much I will flow. Today we have studied total EMF by total resistance, that is R plus R. This R is external resistance and this R is internal resistance, and both are included in this resistance box. Okay, this much. And also we know that if I is equal to this much, we know V is equal to how much? V is equal to I into R. We can say E by R plus R into R, and also it is equal to phi into L2. We have got here. Also we can write value of phi like this. From here, what will the value of phi? From here we can E by L1 into L2 like this. Now use this equation and this equation and solve both of them. Okay, what I am telling? I am telling solve both of them. What you will get? You will get R is equal to R into L1 minus L2 minus 1. This will be the value of internal resistance. Okay, any problem to anyone? Okay, only one thing you have to remember. What you have to remember, that the numerator we have taken L1. You see here, in numerator we have taken L1. When we get L1, when K2 is off. When we get L2, when K2 is on. Okay, this formula only use and solve the question. Anyone, any problem? Anyone, any problem? Anyone? Should I repeat? Okay. All of you, anyone, any problem? Okay. Let us see then. Let us see. Now, we see it and we are going to start with some question. Okay. We have gone through that meter bridge. Okay. We have seen what? Meter bridge. Okay, meter bridge. We have seen potentiometer also, and two of its application which are very frequently asked. One more thing, I tell you one more thing. Sometimes some question comes in your exam to increase the sensitivity. I tell you, because objective question may come, sensitivity of potentiometer. If we want to increase the sensitivity of potentiometer, what we have to do? First important thing, what we do to increase sensitivity, we have to increase this value of potential drop 5, this value of 5, we have to increase this. Okay, first of all, what we have to do, we have to increase this. Okay, we increase this to increase sensitivity. Okay, second, what we do, we decrease the current value by using resistance box. These two things we do usually. Okay, to increase the sensitivity of potentiometer. Any problem to anyone? Any problem? Okay, these are just a point to remember. Just point to remember. Nobody just point to remember. Okay, okay, just is it a point to remember. Okay.